So the assignment for today is 1.3. 1.3 is on polynomials, or more specifically, it's on factoring polynomials. Let me write this down. This one is on factoring polynomials. Factoring polynomials. So let's talk about factoring to begin with. When I write something, so we're going back to what, 4th grade? I think this is when you were introduced to it, I'm guessing. How do I factor 15? 15 can be factored into what? Yeah, 5 times 3. So I'm going to use parentheses. So I have 5 times 3. These are factors. I have 2 factors now. What if I had something like, I don't know, how about let's do something more difficult. 20, no, let's do 24. What are my factors? There's a lot of factors. I could have 12 and 2, right? Or I could break even the 12 down to what? 4 and 3, okay. And then it looks like 4 is certainly a factor. 4 is certainly a factor of 12, but I can break that even down further to what? 2 and 2. So I could actually, through my factor tree, I can see that 24 can be rewritten as 2 times 2 times 3 times 2, right? So these are just factors. What's another way of thinking of factors? If I have 24, I'm trying to find the factor. It's almost like you're trying to find the values that divide out of 24. Maybe it's like a fancy way of saying divide. I don't want to say divide out because divide out goes away, right? If I have 24 and I divide by 2, that just gives me 12. The 2 is gone. So I want to get away from the idea of dividing, but the idea is sort of still there. So let's look at something else. What if I have something like this? Here's another example. So remember, we are factoring polynomials. Actually, let's talk about a polynomial. What is a polynomial? What is a polynomial? So here's my question. What is a polynomial? I saw somebody with their hand up. Is that you, Bryn?
Yes, it was.
Okay, what is a polynomial? Huh?
Multiple things added together. Multiple things connected by multiple things added together.
Yeah, I think so. A lot of things combined together through multiplication, added together. Now, the word added together is separating your terms or your monomials. Now, a monomial and a term are not exactly the same. In fact, it turns out that when we're talking about a monomial, we're talking about something that doesn't have fraction exponents and doesn't have negative exponents. So to hold true with the idea of a polynomial, 3x squared would be a monomial, but 3x to the power negative 2, or 3x to the power of 1/2 would also not technically be a monomial. But I want you to get away from that altogether. In fact, that's not even really relevant when it comes to a polynomial. In fact, we're going to look at negatives anyway when it comes to calculus. So in general, even though it's not entirely true, I want you to think of a monomial as a term. It's not entirely true because if your exponent is negative or your exponent is a fraction, it's not technically a monomial. But for all intent and purposes, for calculus and for today's class, every math that you're going to see, for all intent and purposes, it really is the same thing. So we're going to think of these as terms. Well, what the heck is a term? If I use the verbiage, combine like terms, what do I mean? Bryn.
to basically add or slash subtract, like the things that you can. So basically like the 8x and the 5x, because they both have variable x.
Yeah, so these are the same terms, right? In fact, this is, what kind of function is that? Is that linear, exponential, quadratic, cubic, quartic? What is that piece?
Linear.
This is linear. So do you see how linear terms, those are the same? What's the middle one? What's this one? It's quadratic. Good. It is quadratic. So in fact, we're looking at something that is one-dimensional, and we're combining the one-dimensional things, but we're not going to combine a two-dimensional thing, because that doesn't make sense. We're talking about something that occupies space in a different way. So let's combine, in this case, let's combine the things that are in so if this is, does that make sense that this is one dimensional? Our exponent is one dimensional is left or right.
The same variable.
And you have to have the same variable, right? So it's still one dimensional, but in a different universe, right? If I had something like this, Bryn, if I have, say, 3y, this is still one dimensional, but it's in a different universe.
Yeah.
So I'm not going to combine.
Yeah, I just wanted to point that out.
Yeah, I know. I'm glad you did. I don't want to take this antimatter, which is, two-dimensional, and then take this other matter, which is two-dimensional, and combine them, right? Because you'll get this explosion. So, yeah, so I'm glad you pointed that out. We have to make sure we're in the same universe as well. So we're going to combine the things that are one-dimensional together, and that's going to be 8x plus 5x, which gives us what? 13, yeah, it gives us 13x. So I have 13x. Can we combine anything else? No. So how many terms do we have? 3. We have 3 terms. We have 3 terms. So what do we call this? What is this called? Yes.
Would it be a polynomial?
It is a polynomial. This is a polynomial. This is a polynomial. Polynomial. What does poly mean? It means many. There's many what here? Terms. There's many terms. If I want to be even polynomial is completely accurate. But there's something more specific that I can use for this polynomial, Bryn.
Trinomial.
It's a trinomial. It is also a trinomial. Trinomial. What does tri mean? 3. There are 3 terms, so it is a trinomial. What's our main idea today? It's not just polynomials. Factoring. What does factoring mean? We're breaking something up into factors. Yeah, we're breaking them into factors. We're just some type of multiples, right? We're breaking some number into multiples. What if I had something like this? What if I have 3x squared minus 6x. Can this be factored? How? What's that? A little louder. You have a deaf teacher. 3, 6. 3, 6, and x. Okay, can you help me? Okay. Oh, you take out a 3x. All right, cool. So what we're going to do is take out of both of these, we're going to take out a 3x. If I take out a 3x, then I have 3x, and what's left over?
X squared minus 2x.
X squared minus 2x. Does that look right to you?
2.
Minus 2?
X minus 2.
Yeah, so this is what I would recommend. After you have factored something out, I recommend you multiply it back, distribute back and see if we get the same thing. If I distribute back, what do I get? 3x. What am I getting when I distribute back? Cubed minus,
X.
is that the same?
No, you have to take an X out of both.
Yeah, I needed to take an X out of this one as well. So I did that one wrong. So I think it's really important to check our work to make sure that we did it right. Always distribute back. So what should go inside of the parentheses? Louder? X minus 2. Okay, now we're going to check again. We're going to distribute back and see if we get the same thing we had over here. Do we get the same thing? This is?
3x squared.
Okay, and this?
6x. Negative 6x.
Negative 6x. Yeah, it's the same thing. So we know that we did it right. So this is called, what is this called? This is a what of this? A factor. Why is it a factor?
Because it is the factors of the original.
Yeah, we're talking about this idea of multiplication, right? We're talking about this idea of multiplication. We're trying to rewrite something as multiples of something else. And so here we have this 3x squared minus 6x becomes 3x times x minus 2. All right, so let's do another example. Am I going too fast? Somebody writing something down still? Okay, here's another example. 15x y squared plus about 10x squared, and I want to factor. How do I factor this? Right, we can take out, and if it's helpful, we could write down, just like we did before, write down all the factors of this and all the factors of this. I think this could be helpful. We could rewrite this as, what are all the factors of this? 5, 3, x, y, plus 2, 5, xx. What can we take out of both of these terms?
5x.
Yeah, we can take out a 5x. So we can rewrite this as 5x. So what's left over? 3y squared plus 2x. Now we're going to check really quick. We want to make sure that we did it right. We're going to distribute back. If we distribute back, what do we get?
15xy squared.
15xy squared. That's the same. And
10x squared.
And 10x squared. So we know we did it right. Right, we're going to get into some more difficult stuff. Now we're going to move on to secondary math 2. In secondary math 2, you're given something like this. I have x squared. Let's do minus 3. Let's do 2. 2x minus 15. Can we factor this? Okay. Bless you. Can we factor this?
Yes, it's not in the same fashion as you did before.
Are these factors?
Yes.
Yeah. All right. So what's the rule? When we have some value like x squared plus bx plus c. What's the rule when we factor? How do I get an x plus m and an x plus n? Bryn?
It has to multiply to C and add
So m times n has to equal what?
C
And m, help me out.
plus N has to equal.
Correct. M plus n has to equal b. Do you guys remember this? Okay. So that's how we factor. Let's try another one. So I want to factor x squared minus x plus x minus 20. X plus 5 and x minus 4. How would we check this? Besides using this little recipe right here, how would we check this to make sure that our factors are correct, Bryn? Oh, I'm sorry. What's your name? Jack. How would I check my work here to see that this factor, that these factors are the same as this trinomial? Okay, I hate the word FOIL, and that's not your fault. That's just my personal opinion. FOIL stands for what? Out or outer, inner, last. I hate it because look, what happens when we have something like this? We have a binomial times a trinomial. Yes, let's do something. Let's not make it so difficult. I was actually headed to make something larger than a trinomial. If I do first, outer, inner, last, this is first, this is outer, this is inner, and this is last. What's the problem with FOIL?
4x does not get included.
Yeah, this 4x is not included. How would we do this problem? Don't we have to distribute here as well and here as well?
Yeah.
So instead of FOIL, what if we just call it the distributive property? What if we just call this the distributive property? What if I distribute the x first? I'm done distributing that. And now distribute the 5. We're not doing this FOIL thing. In fact, when did you learn this technique? The distributive property. When? Louder? In 5th grade? I think you learned it in 3rd grade. I wonder, maybe 4th grade, but I think in 3rd grade you learned the distributive property. I'm going to make an argument that you learned the distributive property this is my claim in 3rd grade. 3rd grade, maybe 4th grade, but I'm guessing 3rd grade. What do you do with this? How do I do this? By hand? Yeah, we distribute the 3. That gives us 6. Distribute the 3 here. It gives us 3. Now what? Now you distribute here. And because we're distributing 10, we need to have a placeholder here, right? So what does that give me? What here?
2.
And yeah, so that's going to give us, let's go back. It's going to give us 2 and 1. And then what do we do? Aren't we combining like terms?
Yep.
We're adding the 1s, we're adding the 10s, and then we're adding the 100s. Let's do this to get what? Okay, let's do the same thing with this technique. Let's do this. This x plus 5 times x minus 4. We're going to do the same thing. I'm just trying to prove to you You knew about this. Why are we making it all difficult and calling it something else when you've already learned it?
Because people like to make math for fun.
I think it's somebody else got a PhD for doing something that wasn't really new. They pretended it was new, but it really wasn't. Okay, we're multiplying these. We're doing the same technique. What do we do? Oops, what happened? What do we do first? If we're using the same technique from, when did you learn this? Is that third grade or fourth?
Third.
Somebody's to learn it in second? Awesome. All right, so we're gonna do the same technique. We're gonna distribute here. What do we get? We're multiplying, so we distribute here. What do we get?
20.
We get negative 20. Now we're gonna distribute here.
Negative 4x.
Negative 4x. We have a placeholder. We have a placeholder just like we did before. We're done distributing the negative 4. Now we distribute the x. We're going to distribute here. What do we get?
5x.
Okay, 5x. We're going to distribute here.
X squared.
X squared. So x squared. And then what do we do?
Add.
Combine like terms. We're going to combine these to get
Negative 20.
negative 20. Can add these or combine those.
Positive X.
We get positive x. Combine this. There's nothing to combine.
X squared.
We get x squared. I do not like FOIL. It's one of my pet peeves. I do not like FOIL. You learned about this in third grade. Some of you in second grade. Why create a new name for something that you already know? It's just silly. That's just silly. We're going to use the word distributive property. We're distributing these values. Did we get the same value?
Yeah.
Yep. By using third grade math. We got the same values when we're using third grade math. I'm sorry, shouldn't laugh. It's
Can you go back
up this way.
Yeah. Just so that-
Okay, what I'm gonna do is I'm gonna zoom out. Now, I don't know what you want to see exactly. Is that high enough or more or higher? Okay. Why? It's your choice. You can decide yourself what you believe in or not. Why does Mr. Hall not like the distributive property?
Because or you need FOIL because you.
Oh, sorry. Yes, I do like the distributive property. Why does Mr. Hall not like FOIL? Yes, it doesn't work with everything, right? I don't like it because it doesn't work with everything. It's just, and besides, it's something you've already learned. Yeah, I certainly do like the distributive property. I apologize for that. So are we good? Whoever's copying, did you finish? Cool. Okay, so we're going to move on. Now, this is something that not all students have learned, and so I am a little bit nervous about whether, hopefully this might be something that you just need to get lots of repetition on, maybe from the homework, maybe from reaching out. I can always get another worksheet for you. But if we have something like this, I have two, let me zoom in so we can see this a little bit better. My glasses are fogging up as well. So I want to factor. And I have 2x squared minus 9x minus 5. Did you learn how to factor when your leading coefficient is not 1? Do you know how to do this?
It's been a while, but
Okay.
yeah.
Some teachers don't teach this because they say, well, if you ever have this, say, equals 0, we can always solve for x how? Sorry. Yeah, the quadratic formula. What?
I know the actual thing. I just don't.
Do it. Negative.
Negative b plus or minus the square root.
Oh, you're going to us.
Negative b plus or minus the square root of b squared minus 4ac divided by 2a.
Correct. Nice. That is something you are going to have to remember. I have a master's degree in mathematics. I had to do this even for my master's degree. It shows up. It's all over the place. If you can't factor it, then you're going to have to use the quadratic formula. I should be more specific. If you can't factor a quadratic, then you have to use the quadratic formula. So let's go back and see if we can somehow factor this. Okay, so there is a method that you can look up called the AC method. And I suppose you could go to, I don't know if I have this as one of our videos, possibly. I possibly have it in there. You could look. I'm pretty sure I do. So you could go to YouTube and type in, if it loads, come on, there we go. I'm going to type in AC method, and let's see if the method comes up. Yeah, here's also some quadratics and stuff. Yeah, looks like they do have the AC method. Now, I don't know how to do the AC method. I learned, this is the way that I learned way back when I was your age. This is the way I learned, and this is the way I'm going to teach it just because it's easier for me. If it doesn't make sense to you and you want to learn a different method, look up the AC method. If you don't like my method, look up the AC method. Now, what we're going to do is we're going to somehow have to, so we have, here are our factors. Now, there's something I have to do to this 2x squared. So something goes here and here. Now, there's not a lot of choices of breaking up 2x squared so that we still have, you know, whole numbers and whole variables without dealing with fractions. So we could either have, what's a choice? What? Okay. Yeah. And so this is going to be x here and x here, right? Or I could have 1x on one side and 2x on the other, right? There's not a lot of choices there. Now I'm going to do the same thing with the -5. So there's not a lot of choices here where we're dealing with whole, it's not a whole number, it's an integer. Where we're dealing with integers, we're not dealing with fractions. What are my choices here? What? Yeah, this could either be -5 and +1, or, yeah, there's 4 options, or -1 and +5, or this is -5 and +1, or +5, +5 and -1. Did I get them all? Or, oh, let's list them. I don't know if I hit them all. Here are our choices. Either what goes there, there are 4 choices like Bryn said. Either this is -1 times 5. It could be 1 times -5. It could be 5 times -1. Or it could be -5 times 1, right? This row here goes here, and this row here goes here. Those are the only choices. There are 4 different possibilities. Now, when I do this, when I make this choice of what goes there, this is the last part that has to be true. I need to make sure that these outer numbers, when I multiply them together, that the sum of the product of the outer numbers and the inner numbers, the product of, or I should say, the sum of the products of the outer numbers and the inner numbers equals this number here. Maybe the AC method. Maybe I need to learn the AC method because it might be easier. But all that's going to equal -9, negative 9. So what would have to go? What would have to go here and here so that this product and the sum of this product and this product gives me this?
The one on the right would be -5.
Okay, this has to be -5 and this has to be +1. So the outer numbers would give me what? -10. The inner numbers would give me 1, and that gives me my -9. Yeah, let's write it. Let's write a formula. So we have a times x squared plus b times x plus c. And I'm trying to think of some values of, let's do Usually these are my M and N, so I'll label those. And we'll call this, I don't want to use P and, P, let's do P and Q. P and Q. So I'm trying to think of,
Just leave it with the plus sign on the second one, not look like you're backwards to you.
trying to think of maybe, so what don't you like about my Q?
No, the plus sign. It looks like a back, it looks like a weird T.
Oh, I see.
Thank you.
Yeah. So I'm trying to think of, so this has to go here. So I'm trying to think of a number P and Q that equals A, or maybe I'll write it the other way. Maybe I'll write it the other way. I'm trying to think of A equals P times Q. And I'm also trying to think of another number where C equals M times N, so that P times N plus M times Q equals B. There's our formula. How can we check this to see if we're right? Please don't say FOIL. Please don't say FOIL. Please don't say FOIL.
You?
Yeah, distribute. We can distribute. Yeah, that's one of my pet peeves. I don't like the word FOIL. Just because it's just not very inclusive, like you said. All right, we good there? Yes, no, maybe so. Should we do another one? Let's see if I can find another one like that. Okay. Let's do, I don't know if C works, but we'll try. 3 negative 9 plus 3. 3 negative 9 plus 3. 3 negative 9 plus 3. Factor. I actually don't know, so we're going to find out together. Anybody have it? Is it factorable? You don't think so? Brenda, no?
Yeah,
It is?
I don't think it is.
Let's try
I
it.
think it has to be either positive 10 or negative 10.
Let's try it.
So you keep going off.
So what did you put here?
I did 3x
Okay,
and then x.
you did 3x and x. I think that's a good guess. So both of these have to be, those have to be the products of our B, or for our first term, right? What needs to be here? The products of what? Our last term. What are our choices?
So our choices are either positive 1 and positive 3 or negative 1 and negative 3. And I'm pretty sure these, and then you can flip flop.
Or flip-flop, right? If I try it this way, what do I get?
Then we get
Yeah, 1 and 9, it gives me 10. Yeah, that doesn't work. Let's try it a different way. What if because there's a negative in there, don't you think one of these has to be negative? Because there's a negative here.
Yeah.
Okay, so let's throw in a negative. In fact, the only way that would work is if both of them were negative, right?
Yeah, they both have to be negative.
So if I have a negative here and a negative here,
Then it's negative.
then that, wait. Let's make sure it connects here. A -1 and a -3 is a 3, so that works. So now let's look at the outside. And if I look at this part here, what does that give me? That gives me -1. And if I look at this piece here, that gives me -9, that gives me -10. Well, we could reverse these, right? Let's try that. What if we reverse those?
Then that would be -6 per b.
Oh, well, that doesn't help. So this is -3 and -1. If we look at this and this, it gives us -3 and -3. That gives us a -6. That doesn't work. So it looks like this is not even factorable. Not factorable. Not factorable.
It's not.
So if you wanted to solve for this, if I wanted this, say that this equals 0, how would I solve for this? Quadratic formula, what would be my ABC values?
Three, -9,
And you plug it into what?
b squared minus 4ac divided by
Yeah, just throw it in there and you get your X values. So yeah, that one unfortunately was not even factorable. So we're going to try to find another one that might be more factor out the greatest common factor. Oh, okay. I think they just, in that problem, I think they just wanted us to factor out an X and a 3. They just wanted us to factor out an X and 3. Let's see if we have something. What about this one? So it says factor each of the following polynomials. 3, 2, -8. 3, 2, -8. Let's do that one. 3, 2, -8. 3, 2, -8. Is that factorable? Yes, no, maybe so. Who wants more time? Raise your hand if you want more time. You want some think time. Cool. You want to challenge yourself. This is the kind of math that you need to do. We need to challenge ourselves. It's like, if you just sit, if you want to learn how to snowboard and you go up to Brighton and you watch people snowboard and fall on their butts, you didn't really learn how to snowboard. You have to fall on your butt. You have to try it yourself. That's how math works. You have to learn it. You have to struggle. You have to fall on your butt a couple of times before you learn the concept. So I like that some of you want some think time for this. What's your name? Julian. Okay, so I just need to change the rule. Julian, did you figure this out? All right, so what did you, what did you figure out your factors were?
For 3x squared, I did 3x and x.
Okay.
for -8, I did -4 +2.
And how do we check to make sure that it works?
Multiply 3 times 2.
3x squared, okay. Oh, multiply 3x times x and 3x times 2. So 3x times 2 would give us plus 6x, all right? And then distribute to get -4x minus 6, minus 8, sorry, minus 8. Apologies. And then we combine our like terms. Does that give us, when we combine our like terms, do we get this? Yep, we did. So we did it right, it looks like. So that these are our factors. These are our factors. All right. You want to do another example like this or move on? What if it's what? Yeah, you just you have more choices than to pick from, so that just makes it more difficult. If you add 6 in the front, yeah, it's still factorable. We just have to. You just have more choices. I can't find an example like that, but you know, honestly, it just makes things more difficult. But it's still possible. I just wish I had a better example. Do you want to try another one of those, or should we move on? Okay, let's move on. Okay, so let's look at another way of factoring. What if I have something like this? I have 5. So again, we're going to factor. And I have 5x cubed minus 30x squared plus 2x minus 12. Can we factor out of something from all these terms? No. Can I factor something out of these two terms?
Yes.
What?
5x squared.
Okay, let's factor out of 5x squared. 5x squared, what's left over? X minus 6. Can I factor something out of these two terms?
Yes.
What?
2.
2. So I have plus 2. What's left over?
X minus 6.
X minus 6. What can I do from here? Do you see that this is one term plus another term? Can I factor something out of both of these terms? What?
X minus 6.
Yeah, x minus 6. What's left over?
5x squared plus 2.
Is that confusing? Is it sort of cool that we can do that?
Yeah.
Just another way of factoring. How can we check to make sure we did it right?
Distributive property.
Yeah, the distributive property. We just distribute the x and then distribute the -6 and then combine like terms, we should get the same thing. Would it help if we did that now to prove it to you? Or would it be more helpful if we did another problem like this? Okay, here's another one. I want you to factor. I want you to factor 4x cubed minus 12x squared minus 2x plus 6. Can I factor something out of everything?
Yes.
2.
Yeah. Do we have to do that first? We can do it last as well. We can do it last as well. So what do you want to do? Do you want to factor out the 2 first or last? Okay. If I factor out a 2, then what is left?
X cubed minus 6x squared minus x.
Plus 3, sorry. Plus 3. Okay, now what? We're going to look at the first two terms here in parentheses. What can we factor out of those two terms?
2x squared.
Yeah, so I have 2x squared. What's left over? X minus 3. What about the next two terms?
How can we get a negative
I agree. Let's take out a -1. What's left over in parentheses?
x plus minus 3.
X minus 3. Okay, now what? What can we factor out of both of these terms?
X minus 3.
A minus 3. Yep. So that gives me 2 times x minus 3. What's left over?
2x squared minus 1.
2x squared minus 1. Yep. Formula for this method? I'm trying to think of how we would do that. If I had some, let's try to write a formula for it. The only problem is, oh, well, actually, it's not a problem. Let's try to write a formula for this. So if I have something like this, it was somebody still copying? I don't want to go ahead if somebody's still copying. Okay, if I have something like this, I have, let's use this problem to follow along. So I have, trying to think about it. So I'm going to try to construct this backward. We have, let's look at this one. A plus B times C plus D times A plus B and then I distribute this. Oh, we need X's in there. I apologize. We need X's in there. And then an X here. Copy. Okay. Here's our formula. And then we're going to end with, I have to go both ways. So we're going to get CX plus D times AX plus B. Let's go backward. Let's go, I have to distribute now. I still have to distribute. Hold on. If I distribute here and here and here and here, that gives me CAX squared plus CBX plus ADX plus DB. I don't know if that helps. It just looks messy to me, but certainly that would be your formula, unless I made a silly mistake somewhere. That would be your formula. I think it's easier, instead of looking at it as a formula like this, a step-by-step formula, I think it's easier to look at if something's, it's one of the tools, right? We're collecting, in mathematics, we collect different tools. We collect a hammer, we collect a screwdriver, we collect a saw, and some tools work better with some things than others. The Pythagorean theorem is a tool. Now, of course, when we talk about carpenter tools, we're not going to use a hammer when it comes to a screw. In fact, we're going to cause more damage if we use a hammer. So this is just one technique. You might want to try this as a technique. This is the way that I would do it. Instead of trying to memorize this whole mess here, I think it's easier as one possible technique when you're given a problem like this is, let's see if I have another one. Well, I actually can go here and grab one. One technique is seeing if we can factor something out of the first two terms and then factor something out of the next two terms and see if we have the same numbers to factor a third time. If you don't, then this is not a technique you can use. So this is called factor by grouping. We're going to try, I don't know, try this method. Now, if it doesn't work, it's a tool you can't use. You'll try something different. So what's the first step? See what we can factor out of the first two terms. Now, the first two terms, we're looking at these numbers from descending order, right? 5, 3, 2. And what's this? X to the power. This is 6 times x to the power of what? This is 6 times x to the power of what?
0.
0. Because the 0 exponent rule means it's what? 1. So this is 6 times 1, which is just 6. So we're looking at descending order of exponents. So we're going to, once everything's set up as descending order of exponents, we're going to see, this is just one tool. We're going to see what we can factor out of the first two terms. Can we factor anything out of the first two terms? What?
X cubed.
X cubed. What's left over after I factor out x cubed?
X squared minus 3.
X squared minus 3. What's the rule when I have x3 times x squared? What's the rule? You add the exponents. We add the exponents. That would give us the x to the power of 5. That's why this works when we distribute. All right, now let's look at the second two terms. Let's look at the second two terms. Can I factor something out of those two terms?
Yeah.
What?
-2.
-2. What's left over?
X squared minus 3.
X squared minus 3. Now what?
Now you combine like terms.
We can factor something out again.
We can factor out the x squared minus 3.
Yeah, we can factor out that x squared minus 3. So that's going to give us x squared minus 3 as one of our binomials or one of our factors times what? X cubed minus 2. Yep. And those are our factors. So I think a formula for this is more difficult. Just one of our tools is seeing if we can factor something out of the first two terms and factor something out of the second two terms so that we have another binomial that's the same. What if it turns out that the binomial is not the same?
Then this is not a tool you can use.
Then this is not a tool you can use. Yes, no, maybe so? We're good?
Good.
Okay, here's another method. This was called the factor by grouping, right? This was called factor by grouping. That is the method. That's the tech. That's the tool. That was the tool. Okay, here's another tool. What if I have something like, if I'm going too fast, let me know. Yes, going too fast?
No?
Okay. Guess what the directions are? All right, I have x cubed minus 5x squared plus 6x. Can I factor by grouping?
No.
Why not?
You don't have enough terms.
I don't have enough terms. We factor by grouping when we have 4 terms. I don't have 4 terms. So we have to do something else. Any suggestions? You can't use the quadratic formula because this isn't quadratic. It's what?
Cubic.
It's cubic. There is a cubic formula, but I would recommend not learning the cubic formula. Here is the cubic. What does the cubic formula look like? Cubic formula. Here is the cubic formula right here. It is really ugly, and yeah, I don't think that's something that you want to memorize. I don't know how you come up with a song for this. What is it? The cubed root of I don't know, just messy, right? That's just ugly. That's just so ugly. I have never had to use the cubic formula. I doubt you will have to use the cubic formula. Okay, how would we solve for this? Or sorry, we can't solve. How come we can't solve for this? That's a good question. Can we solve for this? That x equals something. The answer is no. Why not?
It's an expression.
This is an expression, not an equation. Why is this not an equation?
Doesn't equal anything.
Yeah, it doesn't equal anything. I don't know whether this equals 10 or 0. I don't know what this equals. Because I don't know what this equals, I cannot solve for x. Yes, Britton.
We could factor out an x.
Nice.
And
Let's-
then we have a nice quadratic.
Then we have a nice quadratic.
Yeah, we know how to deal with it.
Okay, I think that's a brilliant first suggestion. We factor out an x from all of those terms, and now we have a quadratic. Is the quadratic factorable?
Yes.
Yes.
Okay, to what?
X minus 3 and x minus 2.
X minus 3 and x minus 2. Okay, we just factored it. I wonder if we could find the name of this. That website that I'm on, it sort of seems to have the names of everything. So this one was factor by grouping. That one is factor out the greatest common factor. That's not a fun name. That's just factor out the greatest common factor. Is that one possible? Let's look at that one. Let's see if we can do this one the same method. So let's do this one the same way. Let's do, yeah, this one doesn't have a fun name to it. I apologize. Factor by grouping, that's a fun name. Okay, think time. You guys want some think time?
Yes.
Okay. What are the directions? Factor. Yeah. Ethan, are you stuck? Ethan, what did you do? What was your first step?
Well, I guess I got 2x squared.
Okay, so you factored out a 2x squared. Then what's left over if you factor out a 2x squared?
Then there's the 10x squared and the 5, right?
Yep.
And then
Oh, you want me to start on this side?
the 8x.
So-
power 4 would become 4
Okay,
x to the power 6,
all right.
and then 4x to the power 3 would become 2x, just 2x. Plus 5.
And plus 5. Is there a way we can check it to make sure we did it right? Nice. So we get 8x to the power 4 minus 4x to the power 3 plus 10x squared. Is that the same? So we know we did it right. Is this factorable?
Yes, I difficult.
Well, let's try. I don't know if it's factorable. We just grabbed it off of the website. I don't know if it's factorable. Remember the technique? What do you think, Bryn?
I'll figure out if I can, yeah, I'm still trying.
I don't think it is either.
Yeah, I was gonna say, from when first looking at it, I had this one, so 5. It can only separate into 1 and 5 or -1 and -5.
Yeah, and because there's a negative, it probably is negative, right? So this has to be -5 and -1 or -1, -5, right? Those are the only choices.
Small enough.
What's that?
It might be small enough to get connected.
Yeah, yeah. And so, and then the other choice can either be 2x and 2x or 4x and 1. Yeah, and yeah, I can't seem to get it either. I tried it many different ways. It doesn't seem to work. So we're going to say that that is our factor. We're just going to stop there. Let's see. It does give us a choice here, right? It says down, oh, maybe it doesn't. No, it does right here. It says show a solution. Let's see if they found a different solution. No, it looks like they stopped as well. Yeah, that's the best they did. So I'm satisfied that this is not factorable. Right, there is another, I know we're running out of time. I think we have like 7 more minutes, but there's another idea I want to talk about. And that's something, actually, there's 2 other ideas. So we are running out of time. The other one is if I have something like this, so I want to factor. And I have x to the power 4 minus 11x squared plus 1. It might not be intuitive when you look at this, what to do. But I'm going to rewrite this in a different way and see if this helps you come up with a solution on how to factor. I'm going to rewrite. Do you guys know what this one is? What if this is another law? One law of x1, it says if I have a to the power of n times a to the power of m, then I put the exponents together how? I add them. What if I have a to the power of n times m? We multiply them. Oops, I'm not doing a very good job representing that. M times n. Yeah, we multiply. So I'm going to rewrite this as x to the power of 2 to the power of 2. If we multiply that, does that give us back, bring us back? And then rewrite this as minus 11 times, in parentheses, x squared plus 1. What if I said that a equals x squared? If that's true, couldn't I rewrite this as a squared minus 11x plus 1? Oh, I'm sorry. This was supposed to be a 10. This was supposed to be a 10. This is supposed to be a 10. Oh, 10. Okay.
And it has to be a, or
Oh.
11A.
11a. Yeah, thank you. I made another.
Oh, yeah.
So what can we do then?
Then you can use a to use x, like, you just factor that, because now it's a quadratic.
Now just a quadratic. Yeah. To get what?
X squared minus, or 8 minus 10.
Minus 10
8 minus 1.
and a minus 1. But it wasn't a, it was what?
X squared.
So I could, so we rewrite this as just x squared minus 10 and x squared minus 1, right? And those are our factors. So that's just another technique, another tool for our toolbox. Is there some way we can rewrite the exponents so that we have, something that we would recognize? And we rewrote the exponents with x squared in parentheses in this case. You do have problems? Question? I thought I heard somebody say wait. Okay, so this is the last idea, and I know I wish we had more time to do some more examples like this, but we are running out of time, and I do have one more idea. What if I have something like this? I have x squared minus 49. Is this factorable?
Yes.
Yes.
If it's helpful, you could rewrite this as x squared plus 0x minus 49. What, let me change colors. What does this become? Bryn?
It becomes x minus
7.
7. Thank you. X minus 7 and X plus 7.
Yep. We're trying to think of something times something that gives us negative 49. But when we add them, we get 0. And that would be,
It's something squared minus something else squared.
yep. This is called a what? This is called a what? A difference?
Difference of squares.
Yeah, this is called a difference of squares. A difference, nope, that's not how you spell difference. Difference of squares. Difference means what? Subtract. Squares means squared. This isn't 2 squares, that's squared, and this isn't squared.
That is
Square.
Yeah, it's 7 squared. That we could rewrite this. We could rewrite it as x squared minus 7 squared. It is a difference of squares. If there's a difference of squares, there's probably a difference of cubes. What if I have x cubed minus 27? Now, this is actually something you do have to learn. This is our formula. I don't think it shows up in calculus very much, but it's just something, since this is a review, I wanted to throw this in. This is our formula. Is this a difference of cubes?
yes.
How?
3 cubed.
This is x cubed minus what?
3 cubed.
3 cubed. Now, this is the formula. If I have some a to the power of 3 minus b to the power of 3, then I can rewrite this as a minus b times a squared plus ab plus b squared. I know that looks ugly, but the best way to prove this is by distributing. The best way to do this is by distributing. That gives me a cubed plus a squared plus ab squared minus, did I mess up something? This is a b right here, right? Minus a squared b minus ab squared plus b cubed, minus b cubed, minus b cubed, minus b cubed. And these go away, leaving us with this. The best way to prove this is by distributing to see that the middle values go away. Yeah, we're running out of time though. I'm a little bit nervous. Is that high enough? If there's a difference of cubes, there's also a sum. Actually, let's finish this. Let's finish this. What, based upon our knowledge of a difference of cubes, what should this be? What should this be?
X minus 3.
X minus 3,
X squared plus 3x
x squared, what again?
plus 3x.
Plus 3x. No, because we're just using, we're ignoring that as our AB, right? And so the last one, plus what? Sorry, plus 9. Now, one more, really quick. This is a difference of what? Of cubes. The only difference between a difference of cubes and a sum of cubes is that this negative goes here. So that's the only difference. If I have a cubed plus b cubed, then that equals, that's messy, a plus b times a squared minus ab plus b squared. The only difference between a sum of cubes and a difference of cubes as a factor is that that negative here has been moved. Everything else is the same.